On to example 1-6, which is the ideal gas law and density. So we have a regular propane cylinder for a gas grill has a volume of 33.4 liters. If the cylinder contains 9.1 kilograms of propane and is at a temperature of 25 degrees Celsius, what is the pressure inside the cylinder? And we're given that propane has a gas constant of R is equal to 188 joule per kilogram per Kelvin. That dot there is not supposed to be a degree. That's just the end of the sentence. All right, so we're going to need the ideal gas law, right? What does the ideal gas law look like? Well, that would be P is equal to rho times R times T. So we want to find the pressure, so we'll need the density. The gas constant is given, and we'll need the temperature. So let's start with the density. So rho is, we know, the mass divided by the volume. Our mass is 9.1 kilogram, and the volume is 33.4 liters. But of course, we want to convert that to cubic meters. So we have 1 cubic meter has 1,000 liters. The liters will cancel. So that gives us 272.455 kilograms per meter cubed. All right, so we don't want to round here because this is a result that, of course, we want to move on with. Then the temperature. What do we get there? Well, we have, we know that we are at 25 degrees C, but we want to get to Kelvin, so that'll be plus 273. So we end up with 298 Kelvin. That means we have all our values, so we can say P is equal to rho times R times T. So that would be 272.455 kilograms per cubic meters times 188 joule per kilogram Kelvin times 298 Kelvin. All right, we can punch all the numbers in the calculator. They'll give us something like 15,264,023.95, and then what do you get for units? Well, we can see that the Kelvin cancel out. We can see that we have a kilogram that cancels out, so we get joule per meter cubed. Joule per meter cubed. All right, so that's not what we're looking for. We're looking for a pressure, right? So joule is not going to help us there. So what we know that a joule is equal to a Newton times meter. So let's write down this long number. 15,264,023.95 Newton times meter divided by cubic meter. And that is that whole number again, 15,264,023.95. One of the meters cancel, so we get Newton per meter squared. And again, Newton per meter squared is a Pascal, so we get 23.95 Pascal. And that, of course, we can say in millions, so that we can say that'd be 15.3 megapascals, right? Mega is a million, so that would be our pressure. So we know that if we have this gas cylinder, and if it's 25 degrees C, and has 9.1 kilograms of propane in it, then the pressure will be 15.3 megapascal.